Good morning. So I'm Leo again, and I'm going to present AoT, Authentication of Things. AoT is an authentication and access control solution for the entire IoT device lifecycle. It also enables device from different domains, for instance, a guest device to authenticate to a host device. So it enables device from different domains to authenticate one another. And that's a partnership between Federal University of Minas Gerais, Brazil, and LG Mobile Research. So that's the current situation. The IoT device lifecycle comprises a number of stages. The pre-deployment in factory where the node is manufactured, ordering when the node is purchased, when the device is purchased, deployment when there is the bootstrap home in the user's home, functioning which corresponds to the normal operation of the network, and then the device is trashed. And authentication is a must over this entire life cycle. The problem, we claim that existing authentication solutions for IoT do not meet their needs completely. And why is that? First, because the device deployment or setup schemes, they lack security. The main problem with those schemes is that they rely on a single secret, like the Wi-Fi password in our homes. And if this secret is compromised, the whole secret is compromised as well. We also have the traditional authentication schemes, which are not suitable for IoT, resource-constrained device, because ultimately these schemes, they rely on something completely random, like a public key, and this something random needs to be tied to something not random, like an user, like an entity. And it is very hard, and because it's hard, it's expensive. They rely on certificates, and certificates, as we know, implies computation overhead, storage overhead, and memory overhead. And even lightweight schemes targeting sensor networks that has been studied for more than a decade are not suitable for this domain here, for IoT, because they assume different things. For instance, they assume the sensor net belongs to a single domain, belongs to a single owner, which is false in IoT. In IoT, you may have a guest home. This guest might want to watch your television by operating his personal smartphone. So you have a guest domain, a guest device in a host domain trying to authenticate to a host device. So assumptions are different. So our goal was to devise an authentication and access control solution tailor-made to IoT, and that also comprise the whole IoT device life cycle. And of course, meeting the efficiency and security needs of IoT applications. As a solution to this problem, we came up with AoT. AoT can be set up over wireless mediums, like the current schemes, but it relies on strong cryptography. The security level is higher. AoT is based on a two-domain paradigm, a cloud domain to talk to cloud, and a home local domain to talk to home appliance. And AoT used and abused attribute-based signatures, attribute-based cryptography signatures to provide authentication during this life cycle. AoT relies mainly on three tools, on three crypto systems to achieve its goals. First, identity-based cryptography. In identity-based cryptography, rather than the traditional methods of authentication schemes, public keys are meaningful rather than a random string of bits. So it's pretty much easier to tie those public keys to an entity, to an identity. So it's pretty easy to Bob now to figure out which is Alice's public key. So we don't need certificates here. The problem, it suffers from the key scroll problem. If it's so good, why most of us don't use it, right? It's because it requires a totally trusted entity, IBC, identity-based cryptography. And as we know, in most systems, this entity simply doesn't exist. This entity holds all the private keys, private because it holds, of the system, and then it can impersonate anyone. So it's hard to use IBC. But we used it here in AoT. We also use attribute-based cryptography, which is an extension of the whole IBC ideas, but here the system is based on attributes rather than identities. So users are assigned keys that reflect their attributes. Resources, in turn, are tied to logical expression called predicates. To access a resource, one just needs to sign a request using the keys associated to their attributes. And a BAC is something analogous to identity-based cryptography, but works on the cryptographic level. So we believe it's pretty much nice to IoT because the scalability, it's way higher. We don't have those bunch of access rules, of permission rules. One just needs to assign attributes to users and predicates to resources. So one may use, like us, ABC to implement, to enforce a BAC in a higher level. So now our solution, AoT. I'll first give you an overview, then I will describe a little bit more our main protocols. So recall I told you about the IBC key scroll problem, and to solve this problem, our insight was to come up with two distinct setups, identity-based cryptography setups. And the key scroll still holds, still exists, but it's no longer a problem because request signatures from, for instance, the cloud domain they are invalid in the home domain. And in the home domain, you have a totally trusted entity, like the household owner, the access point, personal device, or if security is a must, if security is a must, a hardware secure module. We use IBC to distribute keys and authenticate the cloud, and a BAC and ABC are used to access control to device operations. Cloud and home domains. IoT comprise, you have protocols for each IoT device lifecycle stage. And I'll first give you an overview of all of them, and then I will describe more deployment, because it's a mission-critical protocol for us. It's where the bootstrap between the device and the home takes place, and functioning, the normal operation of the network. Pre-deployment happens at the factory, so we take advantage of this whole physical structure, this physical security environment, to bootstrap security between the cloud and the nodes. So crypto material is loaded into nodes now. And in the future, they will use that to talk in a secure manner, in an authenticated manner. And they talk about, for instance, updates, patches, etc. And then the factory, the cloud, sends the device to its trader. Ordering is when a user orders and pays for the device. So he goes to the tropicalforest.com, adds that device to its cart, pays for that very device. And after that, the trader tells the cloud, the user, the per user device, the user who had just bought that device. And the cloud sends this user a PIN for later access for later enables the setup of this device. And finally, the trader sends the device to the user's home. Deployment is when the setup of the node of the device takes place. It makes use of that pin to bootstrap the whole process. I will give you more information on that in a minute. And functioning, where nodes use attribute-based cryptographic keys to request operations and to provide operations. Perform. Retirement is just a specific operation, but it's just an operation, but it's a specific one, which is the key erasure, is to get the device ready to be trashed. So we need to first delete all IBC, ABC, and secret symmetrically pairwise keys from that very device. So now I will explain in more detail the deployment phase, deployment protocol. It comprises three main actors: the device that's being deployed, the root user, and the root device. Here, for the sake of simplicity, they are pretty much the same. The home server, the one who holds the keys. Again, it might be an access point, or if security is a must, a hardware secure module. And the goal is to bootstrap security between the device and the home domain. I mean, is to make sure the device gets its ABC keys in a secure manner. So the root got that pin he received from the trader and enters the pin into the device. And the device is then put in setup mode. For instance, it enables the QR code reader of a fridge, of a bulky fridge. Note, the pin input here leverages the physical security of the home, of the kitchen in this case. Only the root holds the pin. Only he got the pin from the trader by using a TLS connection. And it's important to say that the reminder of this protocol does not rely on this pin. It's just to put the device into setup mode. It's just to get its reader enabled. The rest of the protocol relies on strong cryptography. The device then gets from the root device, from the root, the home server's public key. It knows this key is authentic, is legitimate, because it read that from the root device, and the root device is the one, most likely the household owner. So it's a trusted entity. So it believes that public key is authentic. The device generates a secret key, a symmetric secret key, encrypts that secret using the home server's public key, and send that back to the root device. So not even the root device has access to that secret key. It's secured using the home's public key, home server. Then the root relays that key in a signed way to the home server. And now, both the home server and the brand new device share the same secret key, and the home server may rely on this secret to issue the attribute-based cryptographic keys in a secure manner to the device. And now, the device may talk to any other device in the network, like in the functioning protocol. Device may talk one another. So suppose you got home, you are hungry, and you would like to know what's inside your fridge. By using your personal device, you request access to its camera, and the fridge sends you back the attributes necessary, the predicate necessary to perform that operation. I mean, to have access to its camera. Then you pick your keys. You sign the request using the keys associated with the attributes that satisfy that predicate, and sends back to the fridge. And the fridge, in turn, grants you access to its camera. Note here, we are using AoT, so there is a challenge response protocol going on behind the scenes, so no replay attacks are feasible. We also got some extra features, like we enable a guest device to authenticate to a host device in a host domain. So for doing that, the home servers only need to agree on some common public elliptic curve cryptography parameters. Those parameters, they are public, so it's easy to share to each other. As for evaluation, the core of our schemes is the attribute-based signature scheme. And this scheme is expensive because it's based on pairings. And pairings here has nothing to do with the pairing mode of device. It's a crypto primitive that is well known in the community for being expensive in terms of memory and time. And ABS is hard because it doesn't require only the computation of a single pairing, but rather it demands a product of pairings. So we optimize our implementation of ABS by using a multi-pairing operation. Results are now computed only once, stored, and shared by all other pairing computations that demand those results. We use the Relic as our cryptographic library, and our code is publicly available. We evaluate our scheme on top of two classes of reserves, a resourceful device and a resource-constrained device. In LGG4, it's pretty easy, it's pretty fast to compute ABS. 27 milliseconds to generate a signature, and 37 milliseconds to verify the same signature. And in a resource-constrained node like Arduino DUI, generation, it's okay. It takes 1.5 seconds, but the verification is not. It took almost 3 seconds to verify an ABS signature. So we implemented a probabilistic version of this scheme. The security is the same, 128 bits of security. And we cut this figure down to 2 seconds. And then we trade security for speed. We adopt a security level of 80 bits, widely adopted, even though we do not recommend this security level for mission-critical applications. But by doing so, we managed to compute ABS in only 1 second. So concluding, AoT is an authentication access control scheme for the entire IoT device lifecycle. It relies on strong cryptography to bootstrap security. It addresses real-world IoT challenges like inter-domain authentication. And we have evaluated that in terms of performance and security. We have done way more than this. We have our architecture in our paper. We have the security evaluation, formally security evaluation. We have a demo, we have a video. So please be my guest and read our paper. Thank you.
life cycle would be resale IoT device to someone else. So how would this authentication system work, right? I don't want this device anymore. I sell it to my friend or someone.
In fact, we have the, okay, good question.
What was the question?
uh, the question was, he's talking about the device ownership reassignment. So we have a protocol for that in our paper. I mean, due to time constraints, we didn't have time to tell about that. But basically, you set up a new, I mean, it's very similar to retirement. But after that, you generate another PIN and send to the new user, to the new owner of the device. You also have to tell the cloud about the purchase, because he's the one who will generate the new PIN and send to this user, you know?
Okay, I understand, but mostly, I mean, the provider will be done by that time when I sell my device. So if I rely on the cloud server to actually transfer ownership, then it's going to be hard.
In our solution, the cloud makes part of the whole architecture. In our architecture, the cloud plays a key role. There is the binding of the user and the device for patches, updates. So if you take the cloud out of our architecture, that won't work. Yeah.
Another question. David Coates from Dartmouth. You referred to the cloud, but it appears you have many clouds because you have one per manufacturer. And a related question, perhaps, it looks like your model, your protocols are based on online purchasing of these devices, because there has to be an electronic relationship between purchaser and the cloud at the moment of purchase. So can you comment on how well this protocol generalizes to other, to multi-cloud environments, which seems to be necessary, and to more general kinds of acquisition methods for devices? It's also sort of related maybe as well, as it seems to be focused on home IoT. IoT is a much broader concept, and so is this limited to the home, or is there a broader application for these ideas?
Yeah, I agree. In fact, this cloud here is like a variable, right? So you may have different clouds, no problem. In fact, that was prerequisite of our system, of our solution, because if we just have one cloud, things were going to be pretty much easier, because pre-key distribution in the manufacturer would solve our whole problem. So you can take this cloud here, and you can instantiate it. You can instantiate it by with multiple clouds. So the thing is going to be seamless for us. I don't think it's going to be any problem, since we do not assume the device we got home came from different clouds. Not at all. There is no assumption, no requirement. But that's a good question. I mean, you might have the utility, you might have the tropicalforest.com. No problem.
Is there any other questions?